Morning, ladies and gentlemen, and we're going to do Law of Cosines today. Now, for all triangles, Law of Cosines, there are three formulas when you have a triangle with sides ABC and angles across from those sides ABC, and side A squared equals b squared plus c squared minus 2bc cosine A. Now, the lowercase letters are the sides and the uppercase are the angles. The side over here by itself is always the side across from the angle you're taking the cosine of. So the other two formulas include b squared equals a squared plus c squared minus 2ac cosine of b. And the final one is c squared equals a squared plus b squared minus 2ab cosine of angle C. It doesn't really matter what you call the sides and the angles, as long as whatever letter you're using is across from the same uppercase letter angle for side. Now, when we work with this, we're going to start with law of cosines being used when you have two sides and an included angle, and you're trying to find the side across from the angle you're given. So I'm going to erase this so that we have enough room to do all the work. This is all in the book that you are working with, and you can find all the formulas and examples done out in the book. We're going to start with this triangle, ABC. Again, it doesn't matter how you've drawn it. It's just a sketch, so it's not drawn to scale. Angle A, BC. Angle A is going to be 35 degrees. We know that side A is across from angle A. Side B is going to be 6. And side C is going to be 4. Now, in this setup, in the book, when they work with law of cosine, they only round it to 1 decimal place for sides and angles. So that's fine. Just round your answers, the final answer, to 1 decimal place. So we're going to start with A, which is what we're trying to find. A squared equals, now it doesn't really matter which one comes first, but we'll continue to use the formula in the order it's listed. But I usually put the smaller number first, but we can use B. So 6 squared plus 4 squared, that's our A and our B and our C, excuse me, minus 2, now I want to fix that 4, it's a little too small. That's better. Minus 2 times 6 times 4, and up there I need cosine of 35. That's supposed to be up here. I just ran out of room. Gotta use a smaller marker. So let me just cordon that off. a squared equals 36 plus 16 minus. Now I'm going to multiply the 2 times the 6 times the 4 to get 48. And then when we calculate cosine or sine of an angle, we're only going to use 4 decimal places, 0.8192. Now that I've done that, I can go ahead and do some simplification. Notice you can combine these two, but you don't combine this one with these two because this is multiplied times here. So we're going to combine here and we're going to multiply there. A squared equals. Now when I add those two, I get 52. Don't know why I didn't do this separately. Minus 39.3216. So there's my decimal point. When I add these together, or subtract them really, I get 12.6784. So now I need to square root both sides to solve for A. And when I square root both sides to solve for A ends up being A equals 3.56, but we said we were rounding this to 1 decimal place, so 3.6. And that is how you find law of sines to find one of the sides. Use law of cosines, excuse me, to find one of the sides. The next example I'm going to do is I'm going to, instead of giving you an angle, I'm going to give you all 3 sides. So let's erase this and start with a fresh one, fresh board. Boy, it's weird not having you guys to interact with as I do these examples, having to do it all by myself here. All right, we've got R, S, and T. And we have 10, 16, and 22. 10, 16, and 22. Those are the sides. And we're trying to find this angle here. So question mark, or angle R. Now in the book, they put X there, but I actually like using the angle letter instead when I set it up. So when I write this out, I'm trying to use this and this as my main two, because we're trying to solve for angle R. So when I write it out, I'm actually going to be using R, this letter, as my left side of the equation. And when I write it all out, I'm just going to write it 22 squared equals. Now I'm going to put these in numeric order. 10 squared plus 16 squared minus 2 times 10 times 16 cosine of angle R. I have some calculations to do here. So 22 squared is 484, and this might get a little tight here for me writing it all on the board. 10 squared is 100. 16 squared is 256. And then I do this multiplication times cosine of R. And when I do that multiplication, that comes out to 320. Again, one of the things that people get caught up in is they think they can combine this, this, and this. that's multiplied times cosine of r. So I'm only combining these two. 484 equals 356 minus 320 cosine r. Now that I've done that, next step in the process is to get the cosine of r by itself. So I'm going to subtract my 356 from both sides. And that ends up being 128 negative 320 cosine r. Again, you're trying to get the cosine of r by itself, so I'm going to divide by negative 320. Oops. So therefore, cosine r equals, let's see, 0.4. Let me just double check that. Yeah, negative 0.4. Now, I'm going to do inverse cosine. That's that button that says cosine, and usually above that is the second function that looks like that. And that's what I want to use. I hit inverse cosine negative 0.4. And so that leads me to r equals, rounded to one decimal place, 113.6 degrees. There is the result when you solve here. Now, the real interesting part of all this is this can be used to find everything that's missing in the triangle. So we'll try something dealing with that in a second. Let me erase this so that I can write some other things on the board here. Now, these notes that I'm going to put up here now are up there in case you don't have your book, but these notes have to do with the law of when to use law of sines compared to when to use law of cosines. Oops. You're going to use law of sines when you're given two angles and one side, or two angles, two sides, and the angle opposite one of them. So if you're given a triangle and you're given this side, and this side, and you're given the angle across from one of these two, not the included angle. So say you're given that angle. Now you would use law of sines. Now, when do you use law of cosines? Law of cosines when you're given three sides, or when you're given two sides and their included angle. an example of two sides and their included angle. If you're given this triangle and you're given side A and side B, the angle that's made up of sides A and B is right here. That's called the included angle. All right, so that's when you're going to use law of cosines. So I'm going to erase this now because this is all in the book that you're able to use, but let's just erase this for now and do an example. And the instructions for this example is to find all of the angles and sides that are not already given to you. If you're given side A, B, and C, A is 20, B is 14, and C is 18. All right. Now, you may say to yourself, which angle should I try to find first? I am going to suggest that you always, when you're given three sides, by the way, over here, if you saw that like smoke or whatever, that's not smoke, it's a humidifier. And I shut it off so you wouldn't be distracted by it. You might have seen that in the previous video. So, you always want to start with the biggest side, because the biggest angle is always across from the biggest side. The smallest angle is across from the smallest side. And you may say to yourself, well, how does that make any sense? Why would you bother to start with the biggest side to try to find the biggest angle? Well, here's the thing. We know that cosine starts at +1 at 0. Here's +0 degrees. 90 degrees, it's at 0. And let's see, 180 degrees, it's at -1, +1. So this sine curve comes down like this. I didn't do